Okay, we're going to continue where we finished off earlier. We have calculated the left-hand side, the left-hand column, the web. Objective is to locate the position of the neutral axis. Okay, I'm going to do it again. Maybe earlier I was a bit rushed. So now we are going to focus on the right side. Well, what did I call earlier? Right what? Right hand column. Of the web. So what we are doing is we're going to find along this red line, okay, where the normal stress is equal to 0. So the formula that we are going to use is stress X. This would be equal to 1.359 times 10 to the power 6. Okay, and this is positive because the axial load is inducing a tension. The next part I'm going to write, like what I told you, is the true form of the formula. Okay, so if you look at the formula sheet, the formula sheet will write this. Okay, so this is the same as the formula sheet. Okay, like I explained earlier, for this case, I'm going to draw in red what it means based on that formula in the box. Is this is your y-axis, okay, and then moment about y, this is a positive direction. This is the z-axis, and moment about z, this is the positive direction. So what we realize that our moments are both what? Negative. Okay. So on the right hand column, what we realize that z now is equal to minus 0.01 divided by 2. So it's equal to minus 5 times 10 to the power minus 3 meters. Okay. Because it's on this side z is what? Negative. Okay. So we want to identify the position of y such that the stress is equal to 0. So now all you need to do is put this equal to 0. This is equal to 1.359 times 10 to the power 6. You put plus. This will be equal to 210 over 104. My, our moment about y is what? Moment about y we did calculate. It's 375. Right? Now, our 375 now, our moment about y is also negative, right? So minus 375. Z now is what? Minus 5 times 10 to the power minus 3. And then we're going to divide by our IYY, which we found that's equal to 2.859 times 10 to the power minus 6. And then we're going to minus again. And this is equal to 210. Sorry, it was 200. We did not use 210. I do apologize. 200 over 104. And then our moment about z is again negative, minus 17.936 times 10 to the power 3. Then this is the y that we would like to acquire. And over here, this is equal to 65 IZZ is 65.694 times 10 to the power minus 6. Okay. So if we were to look at our previous equation, okay, this is what was before. So let me look at these numbers over here. It might help us in our calculation. Okay, so the first set of numbers are the same. Now this one is different. You have a minus down here rather than a plus. So minus minus will become plus. The value is the same. And then the last one, everything is the same. So this is going to be minus minus will be plus 525.045 times 10 to the power 6y. Okay. So from here, our answer will be slightly different. So this will be equal to 1.359 plus by 1.261 is 2.62 times 10 to the power 6, 1.359 plus by 1.261. And then plus by 525.045 times 10 to the power 6y. So y is equal to minus 2.62 times 10 to the power 6 divided by 525.045 times 10 to the power 6. Okay. So minus 2.62 power 6 divided by 52, 525.045 power 6 is equal to 2.62 divided by 525.045 is equal to 4.99 minus 4.99 times 10 to the power minus 3 meters, or minus 4.99 times 10 to, or this is millimeters. So what this means, okay, so if we go back to this diagram again, right? So what this means, so if I'm going to sketch the centroid out, so this is our centroid. Okay. And so this is our YY. And then this is our ZZ. Okay. So on one side, it is what? 0.186 millimeter on the left-hand side. So this is just a sketch. So 0.186. Okay, so I'm going to draw in orange. So this is 1 point. And the distance from here to here is 0.186 millimeters. Okay. Y down because it's negative, right? So anything above Y is positive. Anything below Y is negative. And the other one is 4.99. So 4.99. So this is the distance. Again, it's negative. Okay. So now if I'm going to draw a line, an orange line, okay. So this is a sketch for the orientation of the what? So along this line, stress X will be equal to what? Will be equal to 0. Anything on this side will be under what? Tensile. Anything on this side will be under what? compression. That is why for brass, we don't need to check for what? Compression. Are we clear? Okay. So this is the full blown, hold on, of how, okay, regarding bending, okay, that you are expected to know. Yes. Yeah. How do we know what? Find the, yeah, because how do we know? Because over here, when we did our analysis, you have maximum tensile and maximum compression. You can do the same thing and check, and you will not get anything that is going to be under compression. You can do the same test procedure. We did not know the earlier. Only after this we know. Okay. Right. Yes. Because I want to find at this location along the red line, right? What is constant? Z is what? Positive. 0.005 meters. On the green line, Z is what? Negative. That's all. That is a coordinate system. Why should we? Because we know the red line will lie a position of the neutral axis. The green line also, but exactly where we don't know until we substitute into this equation over here. Until we use this equation over here. Right? We do know what? Okay. Let me reiterate. On the green line, what coordinate system is fixed? Where we have Z is equal to minus 0.00 what? 5. Right? So that's why over here we put minus 0.005. We don't know where Y is. We don't know where it intercepts where the normal stress is equal to what? 0. Is the explanation better or I just went louder? Good. The next part, I'm going to do, I want you to practice this theory over here. Okay, I'm going to copy and paste. It states when the applied force is perpendicular to the centroid, the perpendicular distance is to the point of failure. If the applied force is parallel to the centroid, the perpendicular distance is to the centroid. It's just words. Only if we put into practice, then we can appreciate it, okay? Before we go on, can someone tell me what is a moment? What is moment equal to? What is a unit for moment? Now, what is a torque? Force times what? What is the unit?